Newton's first law of motion. This law is called as law of inertia. So for studying this Newton's first law, we perform one experiment. We take a glass jar as like this one, empty glass jar. At the open end, we place a postcard or cardboard. On that cardboard, we place a coin. Now we have to study the property of inertia, or what is inertia. With the help of this experiment, we can study the Newton's first law of motion. So initially, when a coin is placed on the card, we give motion to the card in such way that card moves fastly, but coin is dropped in the jar. Why such is happen? Because there is inertia. What is inertia? It is the inability of an object to change the state of rest or of motion along the straight line on its own. That is called as inertia. So first of all, what is inertia? Inertia, it is the inability of an object to change state of rest or of uniform motion in a straight line on its own. That is called as inertia. And due to inertia, coin dropped in the glass jar. So with the help of this one, we can write this statement for Newton's first law of motion. If we consider another example. In this example, if we consider this block, no force is acting on the block, then block remain as it is. And if we apply force, then block moves. This is the Newton's first law of motion. So according to this one, we can say that an object continues its state of rest or of uniform motion in a straight line unless an external unbalanced force acting on it. If no external unbalanced force acting on that body, then body remains as it is. If it is in the state of rest, then it remains in the state of rest. Or if this body is moving with uniform speed along the straight line, then body moving continuously along the straight line with uniform speed. If no external unbalanced force acting on that body, this is the first law of Newton's first law of motion. Now for example of this law, if we seated in the bus and bus start fastly, we pull in backward. If brakes are applied by the driver of the bus, then we pushed on the forward side. This is also examples of Newton's first law of motion. In that case, body acquires inertia. And we know the inertia. Inertia means inability of object to change the state of rest or uniform motion on its own. So this is about the Newton's first law of motion. Now we have to study the Newton's second law of motion. For Newton's second law of motion, we know the momentum of a body. Before studying the second law of motion, we have to study about the momentum. When body moves with velocity v and body having mass m, then its momentum is given by m into v, where m is the mass of the body and v is the velocity. So according to this formula, we can define the definition of momentum. Very simple definition. The product of mass and velocity of a body is called as momentum. Regarding to this formula, we can define the definition of momentum. Very simple definition. Momentum means product of mass and velocity. Now, what is about the rate of change of momentum? Rate of change of momentum. In case of rate of change of momentum, we consider change in the momentum means final momentum minus initial momentum. Final momentum upon minus initial momentum upon time. Now final momentum, if body is moving with final speed v and initial speed u, then final momentum is mv, where m is the mass of the body. Initial momentum is mu, u is the initial speed or initial velocity, and time is given by t. And this is equal to rate of change of the momentum. Now, by taking common m, we get m in bracket v minus u upon t. V is the final velocity, u is the initial velocity, t is the time. And we know that this acceleration is equal to final velocity minus initial velocity upon time means change in the velocity. So, instead this we write a, so we get m into a, where a is the acceleration. So this is equal to rate of change of momentum. Now we study the statement of the second law of motion. So according to Newton's second law of motion, the rate of change of momentum is directly proportional to force, and this rate of change of momentum is in the direction of force. So this is the Newton's second law of motion. Means this rate of change of momentum is directly proportional to force, and both having same direction. Means rate of change of momentum is in the direction of force. But we know that this rate of change of momentum is equal to ma, and therefore according to Newton's second law of motion, we get rate of change of momentum is directly proportional to force. but this rate of change of momentum is ma, so we get F is directly proportional to m into a, and finally we get this F is equal to constant of proportionality k into ma, where this k is constant of proportionality. K is constant of proportionality. And in this case, this k having value 1. Then we get this equation F is equal to only ma. In this way we get formula for force. Force is equal to mass into acceleration. So with the help of second law of motion, we get formula for force. So remember this second law. According to second law, we get the rate of change of momentum is directly proportional to force, and this rate of change of momentum is in the direction of force. Now we have to study the Newton's third law of motion. If we consider Newton's third law of motion, in that case we study about the example of launching of the rocket. In this case, rocket is moving in upward side. This is action force, and earth exert force on the rocket. This is reaction force. Both these forces having equal magnitude, but directions are opposite to each other. So according to this example, we can explain the Newton's third law of motion. Here we consider only action and reaction. This action and reaction both are having equal magnitude but opposite direction. So we write here, to every action there is equal and opposite reaction. There is equal and opposite reaction. Very simple statement. This is Newton's third law. For studying Newton's third law, if we consider example of bullet fired from the gun, this is also one example of Newton's third law. So according to this Newton's third law, remember the statement of that law: to every action there is equal and opposite reaction. Now we have to study the law of conservation of momentum. As we know that momentum is a product of mass in the mass and velocity. Law of conservation of energy, or law of conservation of momentum. Remember the meaning of conservation. Conservation means remains constant. Which quantity remains constant? Momentum remains constant. For studying the law of conservation of momentum, we consider two different bodies. This is body A of mass m1 moving with velocity u1 in this direction. Then its momentum is given by, according to the formula of momentum, it is product of mass and velocity. So momentum of body A is m1 u1. If you consider another body of mass m2, body B, and its velocity is u2, then this also moving in this direction. Then momentum of second body is given by m2 u2. But this u1 is greater than u2. This velocity of body A is greater than velocity of body B. After some time, body A collides on the body B. And after collision, body A and body B are separated. Body A moves with velocity v1 after collision, and body B moves with velocity v2 after collision. Then after collision, body A having momentum m1 v1 and body B having momentum m2 v2. So according to law of conservation of momentum, we have to prove this. The sum of this momentum is equal to sum of these two momentum. Means momentum before collision is equal to momentum after collision. This is the law of conservation of momentum. So for that purpose, at the time of collision, these forces F1 and F2 are equal. Its magnitude are same, but directions are opposite. So we write here F1 is equal to minus F2. Now we have to find out force F1. So F is equal to ma. So we get F1 is equal to m1 a1. A means acceleration. Acceleration means the rate of change of velocity with respect to time. So m1, first body. So we get final momentum of first body. Final velocity is v1. Initial velocity is u1 and time is t. So we get F1 is equal to m1 v1 minus u1 upon t. This is equation 1. Now F2 is equal to m2 a2. Mass of second body is m2. So that is equal to, after collision velocity is v2. So v2 minus u2 upon t. Equation second. As you know that these forces are equal but directions are opposite, therefore we write F1 that is equal to F2, negative of F2. Then we get m1 v1 minus u1 upon t, that is equal to minus m2 v2 minus u2 upon t. This tt get cancelled. Then we get m1 v1 minus m1 u1, that is equal to minus m2 v2. Minus minus will become plus m2 u2. Now this is minus m2 v2 on that side will become plus. So we get m1 v1 plus m2 v2. Now this minus m1 u1 on that side will become plus. So we write m1 u1 plus m2 u2 as it is. Now see this one. This is the total momentum after collision. And this one is the total momentum before collision. In this way, we prove the law of conservation of momentum. If no external force acting on the body, then linear momentum remains constant. Means total momentum before collision is equal to total momentum after collision. So this is the proof of law of conservation of momentum. So in this way we study the law of motion. I think everybody understood this. Thank you.